Okay, so this is a screencast on linear motion and the suvat equations. So these equations of motion, or suvat equations, are called suvat because they involve S, which is displacement, U, which is initial velocity, V, which is final velocity, A, which is acceleration, and T, which is time. So it's possible to derive each of these equations one by one, so that we get them into the form that you're familiar with. But these equations are already given to you in your data booklet, so it's not really necessary to derive them here. However, the skill of derivation is very important, and I would say that you should look at the starting point for each of these equations, understand where they come from, and practice deriving them, because you will need to be able to derive a number of different equations later on in the syllabus. So we have our 4 equations here, and then we're going to use them. And they're very, very useful equations because they allow us to solve a number of different types of problems, as long as you enter your individual quantities, displacement, initial velocity, final velocity, acceleration, and time very carefully, taking into account particularly the direction of the vector components of a given problem. These equations can be used to solve a whole range of different problems. So let's take an example problem. So let's say we have a car, and that car is going to start from rest. So any time that you see in a question from rest, you should be writing down u is equal to 0 meters per second. And it's going to travel across some displacement to a new position. And we'll say that displacement is 65 meters, and the time that it takes to travel those 65 meters is 15 seconds. So I can solve a number of different things here. Let's say that I want to solve the final velocity. So basically the first thing that I need to do is to choose which suvat equation I'm going to use, and that's going to depend on the information that I've been given. So you can pause the video for a second and try to decide which suvat equation you actually want to use for this question. Okay, so hopefully you've had a look at the different equations. You're trying to decide which one to use. You'll notice if you look at the first equation, for example, V is equal to U plus AT. We can't necessarily use that equation because we don't have a value for acceleration. Now maybe we'll use some other formula to solve for acceleration, and then we can use that formula. But in this case, there's a formula that I can use straight away. It's the second suvat equation, S is equal to V plus U over 2 all times T. And I know I can use this because I only have one unknown in this case. I've been given a value for S, for T, and for U, so I can solve for V. So I can just get rid of U straight away because that's 0. And then it's very easy to solve for V. So I find that V is equal to 8.67 meters per second, and I'll underline that. Now what if I wanted to calculate the acceleration? So I could have done this before if, for example, I wanted to use the first suvat equation. But if I haven't been asked for it, I'm not necessarily sure whether I'm going to need it or not. I'm not going to waste time doing that. But now I'm being asked to calculate acceleration. And by the way, I should mention that these questions only work where a body has uniform acceleration. So either that acceleration is 0, it doesn't have any acceleration, or it has some constant acceleration. Zero acceleration, 0 meters per second squared, is constant acceleration. But it'll only work for questions with uniform or constant acceleration. So I choose which suvat equation to use. In this case, I'm going to use the first suvat equation. Again, U is just 0. I fill in my values, and I very easily solve for A. So I underline that. Now, what if I wanted to calculate the displacement after 1 minute? So you'll notice in the current example, the position of the car here is at, up here, is at 15 seconds. So after 1 minute, the car is going to be further on down the line somewhere. Okay, so a different time value and a different displacement value. if it's still accelerating, by the time it reaches this point over here, it's also going to have a different final velocity. So we need to be careful here. We can't use our final velocity from part 1. So we need a different equation. So pause the video if you want to try this and see which equation is most suitable in this case. So the equation I'm going to use is S is equal to ut plus a half at squared, the third suvat equation. So again, I can just get rid of ut because u is 0. Now that assumes that I'm talking about this being the start of the journey. Okay, so if I'm taking it from this point here through a full minute, 60 seconds, over to some new position over here, wherever the car is after 60 seconds, then I can say that u is 0. So S is equal to at squared over 2. I fill in my values, and I get that S is equal to 1040.4 meters. Now, because we want to get into the habit of using correct scientific notation, I'm going to rewrite that as 1.04 kilometers. Okay, I could write it as 1.04 by 10 to the 3 meters, but because 10 to the 3 is kilo, I'm just displaying that with its prefix. Either is fine though, but we should try to represent our answers in correct scientific notation whenever possible. And then if I asked for the final velocity after 1 minute, so which equation am I going to here? Again, you can pause the video, give this a go. Well, there's a number of equations I could use, but in the interest of using all 4 equations, I'm going to use the final suvat equation, which is v squared is equal to u squared plus 2as. So v squared equals 2. Well, again, now when I'm trying to decide like what my value for u is going to be, that's going to depend on what point in the journey I consider my starting point. Okay, so I can consider this my starting point, or I could consider this point over here my starting point, and I could find the I could use a velocity of 8.67 meters, which I found as the final velocity earlier, right? This value over here, this was the final velocity. But I could say now, forget about everything that came before. I'm going to use this as my starting point, and I'm going to say that the initial velocity here is 8.67 meters per second. So in the previous example, we would have been calling that v, but now we'd call it u if we wanted to do that. But for simplicity's sake, I'm going to start from this point in the journey first. So I'm going to say that u is equal to 0 meters per second because the car is starting from rest, and so my equation simplifies to 2as. I fill in my values, and I find that the velocity is equal to 34.67 meters per second. Now I could do it the other way. I could use this as my starting point. So if I said v squared is equal to u squared plus 2as again, but this time I use my value of 8.67 meters per second as my initial velocity. Fill in all my other values, I get the same answer. And this is a useful way of verifying my answers. By doing that, I've actually verified more or less in my own head that this value must be correct. And that in turn gives me confidence that the rest of my answers are correct, or at least any answers that involve that answer. Okay, so let's look at a more complicated example now. So there's a man standing on a cliff. He's holding a rock, and he's holding that rock a distance of 1 meter above the ground. And he throws the rock up in the air. And he throws the rock up in the air with a velocity of 8 meters per second. So the rock will reach some maximum height. It'll stop for a second, and then it will start to travel down. It'll reach its original position in space, right at the same level it was in his hand, and then it'll continue to the bottom of the cliff. And we'll say that whole journey from the time it left his hand to reaching the bottom of the cliff took 5 seconds. So there's a number of different things we can calculate from this. First thing I want to calculate is h max, and we have to think about what h max is. It's the maximum height above the ground that the stone will reach. In this case, when I say the maximum height above the ground, I'm talking about from the ground here to the maximum height here. So I'm going to call that h max. So as soon as you're thinking about an object that's in flight and that object reaching its maximum height, you should be thinking a velocity of 0. because as soon as the stone reaches this point, it's going to stop for a second. It's going to slow down and stop, reach a velocity of 0, and then it's going to start to travel in the opposite direction. So we can say straight away at h max, the velocity, the final velocity equals to 0 meters per second. So I'm going to use this equation. V squared is equal to u squared plus 2as. V is equal to 0, so V squared just cancels. And now this is where I need to be very, very careful in filling in my values. So U is the initial velocity. The person throws the stone up in the air with a velocity of 8 meters per second. That means that as soon as the stone leaves his hand, that's the moment the journey of the rock starts. So the initial velocity of the rock is the velocity just at the instantaneous moment it leaves his hand. In other words, the initial velocity is 8 meters per second. So I'm going to say 0 is equal to 8 squared plus 2 times. Now, my acceleration value, this is where I have to be really, really careful. I said that the stone travels upwards with a velocity of 8 meters per second. It's slowing down. It's slowing down because there's a force acting on it. In other words, there's an acceleration acting on it. Any object that experiences a force also experiences acceleration due to that force. That's Newton's second law. And the other part of Newton's second law is that the acceleration is always in the same direction as the force being applied to the object. So, what force is acting on the stone as it travels up through the air? The only force acting on it is gravity, apart from air resistance, but usually we assume that air resistance is negligible unless the question specifically mentions air resistance. Okay, so if air resistance is negligible, the only force acting on it is gravity, and gravity has a value of 9.81 meters per second squared. But because I said that the velocity in the upward direction is 8 and acceleration must be acting downward because that's the direction that gravity acts, I have to give that gravity value a minus 9.81 value. That minus is really important because it signifies the direction. And I said before, if you're really careful with how you input all your values into these suvat equations, then they give you really nice simple answers. But it relies on you to be very careful with how you input your data. So all that times s, which is what I'm interested in finding out. So I solve for s, and I get that s is equal to 3.26 meters. But remember, this is giving me from the time, from the moment that the stone left the person's hand through a displacement here to this maximum height. So this is the displacement from the starting point to the maximum height. Is that the maximum height from the ground? No, it's not, because he already held the rock 1 meter above the ground before he started. So I have to account for that, and I'll say that h max is equal to 4.26 meters, therefore. What if I wanted to calculate the time to reach the maximum height? This is a little bit simpler. I can just use one of my suvat equations again. V is equal to u plus 8t, the first equation. And I rearrange that to get time by itself. Again, velocity is just going to be, or the final velocity v is going to be 0. So I say that time is equal to minus u over a minus, well, u is 8 over minus 9.81 again. So acceleration minus 9.81, and that gives me a time of 0.82 seconds. So it took 0.82 seconds to reach this maximum height. Now what if I wanted to calculate the height of the cliff itself? Well, there's a number of different ways that I could do that, okay? But what I'm interested in is this height right here. Now there's no way for me exactly to figure out that height. If I knew the initial velocity at this point right here, I could figure it out pretty easily. So I have to think about at some point along the journey that I do know the velocity, that I have all the information that I need. And I think the easiest point to start from in this case is the very beginning. And this is the handy thing about using these suvat equations when you do them correctly, is that the equations themselves take into account the change in direction here. They take into account the hang time here for a second with a velocity of 0. Okay, so the equation, as long as you enter all the data in correctly, it will give you a displacement, if that's what you're looking for, from this point right here to the bottom of the cliff. So I'm going to use this equation. S is equal to ut plus a half at squared. And remember, the displacement S is the straight line distance from the starting point to the end point of a journey, wherever you define that end point to be. So we're saying the end point is down here at the bottom of the cliff. So this is our starting point. It takes 5 seconds to travel up and then back down and hit the bottom of the cliff. But the straight line distance from the starting point here to the finish point here is this displacement. So in other words, this distance here, or this length here, is equal to the displacement starting from here in this direction to the bottom of the cliff. That's the displacement that I'm going to find. So as long as I put in all my values correctly, you notice here I have a positive value for 8, which is in the upward direction. Time is 5 seconds. It's a scalar quantity, so we don't have to worry about direction. Again, my acceleration is minus 9.81. My acceleration is always minus 9.81 because the direction of acceleration hasn't changed at any point throughout the journey of the rock, no matter what way I rearrange the question. And it's in the opposite direction to my initial velocity, and it's in the opposite, or it's in the same direction as my displacement. So the acceleration in this case is going to be in the same direction as my displacement. That tells me my displacement should have a minus in front of it when I work it out at the end. And that's going to be a way for me to check my work. So I solve for S and I find that S is equal to minus 82.63 meters. But remember what S is. S in this case is this value right here. And I'm interested in H. So the absolute value of S, if you like, is 82.63. The real value for S is minus 82.63 because that tells me the direction. But the absolute value, or the magnitude of S, is 82.63. So I can subtract that 1 meter extra that the rock was above the top of the cliff, and I find that the height of the cliff is 81.63 meters. And finally, if I want to find the velocity of the ball on impact with the ground, I'll use my equation V is equal to U plus AT. And again, it depends on what point in the journey I decide to start from. You know, I could say I'm going to start from here with a U of positive 8, an acceleration of minus 9.81, and a time of 5 seconds. And that's going to tell me, again, it's going to account for traveling up, stopping, traveling back down, and hitting the ground with some final velocity V. That's going to give me that value V. I could as easily start with an initial velocity of 0 right up here. Okay, so if I know the maximum height here from the top of the cliff to its maximum height, and I add the height of the cliff, then I'll have the displacement of the stone as it falls from this point to this point. Okay, I could subtract the time that I found from part 2, which is 0.82 seconds, from the total time, 5 seconds, and I could find the time that it took to travel from this point down to this point right here. And so I could choose that as my starting point. In this case, V, it was V before, it was V is equal to 0 meters per second. Now I'd be calling that U, so I'd be saying I'm starting my journey from here. Yeah, but in this case I'm going to start it from the very beginning. Okay, so I'm going to fill in my values, again being careful of my positive and negative signs, and I get a velocity of minus 41.05 meters per second. And again, that minus is a hint to me that I'm probably correct because it's in the correct direction. The velocity would be in this direction. Yeah, but I could do it another way. So I could use a different equation. V squared is equal to U squared plus 2AS. And the handy thing about this one is that it doesn't care about the time, right? So there's no time in this equation. So in this case, I'm going to start from this position right here, from when the stone travels up and back down to its original point in space, but traveling in the opposite direction. So in this case, I need to know what my initial velocity will be at this point, and what's the displacement from this point to the bottom of the cliff. I have acceleration already, it's always going to be minus 9.81. Well, the displacement value I already worked out, it's this, S, right, which was 82.63 meters. What about the initial velocity? Well, I know what the initial velocity is. It's minus 8 meters per second, because if the stone left the person's hand with an initial velocity of 8 meters per second here, then the magnitude of its velocity at this point will be the same. But because it's traveling in the opposite direction, we put a minus sign in front of it. So in other words, the velocity of the object when it reaches its original position again after traveling up and then back down will be minus 8 meters per second. So I could use that as my starting velocity. So I'm going to fill that in, put in all my other values, and I solve for v again. And I find that v is equal to 41.05 meters per second. And in this case, I don't have a minus in front of it, so I'm just going to define the direction. I'm going to say south, or I could say downward or something like that. Okay, but I've gotten the same magnitude, so I'm pretty confident that the answer is correct. Okay, so that's the screencast. Really, in order to get proficient with these equations, you just need to keep practicing them, and probably the most important thing is getting used to defining the direction and inputting all your data with the correct sign depending on the direction that you're choosing. Okay, so watch through this video as many times as it takes you to fully understand this topic, and then do as many questions, as many practice IB questions as you can find while using this video to check over your work and make sure you're doing it correctly.